Welcome to Spark Academy, dear student. I am Nityanand Ghosh, physics faculty here. So last class I started teaching you motion of a particle or a body on a plane. Plane means actually it is two-dimensional or three-dimensional. So the important topics covered here is some vectors, resolution of vectors in 2-dimension, 3-dimension you have to know, and then related problem, that relative velocity problem, boat and river problem, and then your rain and man problem, and then projectile motion, and then uniform circular motion, that has to be discussed under this topic. So last class I taught you few topics. Now let me skip those topics and then let me proceed. Okay, all these vectors about already I told you. From here you need to concentrate. Okay, so the important thing is that resolution, how you resolve a vector. Suppose a vector is in some direction r, okay, in a plane, xy plane, this is x, this is y, xy plane, z axis will be perpendicular to the board, let's say. So you resolve this r into two components, let's say rx and ry. Rx will be equal to r cos theta and ry, this will be in the x direction, and along the y direction ry will be equal to ry sin theta. So this is how you have to resolve r. One is rx cos theta and other is r cos theta, r sin theta. And this r is nothing but magnitude of this r. Position vector r is this OP. This is OP. Okay. R is nothing but magnitude of this position vector. Okay. Magnitude of this position vector will be Rx. Magnitude of this position vector will be equal to Rx square plus Ry square. What is Rx? Rx is equal to R cos theta and Ry will be equal to R sin theta. R means actually this magnitude. Okay. So this resolution you have to know. Now, resultant of first parallelogram of law vector. Parallelogram law vector also I taught you last class. If two vectors acting at a point making an angle theta with each other represented both in magnitude and direction by the adjacent side of a parallelogram, then the diagonal drawn from the same point will be the resultant both in magnitude and direction. So what I mean to say is, if P is one vector and Q is another vector, the angle between them is theta, then the resultant will be the diagonal of a parallelogram. You can complete this, it will be resultant of a parallelogram. Okay. So, so this is P and this is Q. So here the resultant R formula is, direct formula is R will be equal to square root of P square plus Q square plus 2PQ cos theta. This will be the resultant ka magnitude. Okay. So this last class I told you how to get this R actually. So now you have to remember the formula. R is equal to P square plus Q square plus 2PQ cos theta. And angle between this magnitude, this resultant with this horizontal is nothing but it is given by tan alpha is equal to Q sin theta by P plus Q cos theta. So this formula you need to remember, and there are different cases. Theta is equal to 0, what happens? Theta is equal to 180, what happened? Theta is equal to 90 degree, what happened? And there are some special cases. Once you know the formula, then you can put the values, theta values, and find out. Now this is triangle law vector. What is triangle law vector? If two given vectors are represented both in magnitude and direction by the two adjacent sides of a triangle taken in order, then the closing side, third side taken in the reverse order, will give the resultant both in magnitude as well as direction. Suppose OA is one side of a triangle. it is represented by P vector, and AB is another side represented by Q vector. The resultant R will be equal to this P plus Q. This will be the resultant. The third side taken in opposite order. So this is your P, this is your Q, and this is in opposite order is the resultant. Okay. Now this particular actually logic is applied here, law of equilibrium of forces. If three forces represents the three sides of a triangle taken in order, then the resultant is 0. If such forces acts on a particle simultaneously, then they keep that particle in equilibrium. Okay, suppose if three forces are taken in order like this, first force is like this, second force is like this, and the third force is like this, taken in order, this is a closed system, then the resultant force will be equal to 0. The body will be at rest. Okay. Now another logic, same Lami's theorem it is called. If a body is in equilibrium under the action of three coplanar concurrent forces P, Q, R at angle alpha, beta, gamma, then the ratio of the magnitude of one of the force to the sine of angle between the other two forces is always constant. What is the meaning? Suppose you take P as one force. So opposite side P, Q and R are three forces. So the opposite side of P, the angle subtended is alpha. So this will be sine alpha. So P by sine alpha, okay, is equal to Q. Q ka opposite angle is beta. So Q by sine beta is equal to R by opposite angle is gamma. So this is equal to constant. Okay, like that if some problems are there, then you can solve. Now, what is polygon law of vectors? You know, if there are number of vectors in this particular order, if number of vectors of same kind acting at a point in the same plane in different directions are represented both in magnitude and direction by the adjacent sides of a polygon taken in order, then the closing side taken in reverse order will give the resultant both in magnitude and direction. What is the meaning? Suppose this is A is one vector OA, now AB is another vector B, so its resultant will be A plus B, A plus B. Now another vector C is there in this particular direction. See, these vectors will be there in isolated manner. You have to attach them to apply the particular law. Now if C is another vector, then its resultant will be A plus B plus C. Suppose D is another vector, then A plus B plus C plus D will be this vector. If E is another vector, then the resultant will be like this, it goes on. Resultant will be A plus B plus C plus D plus E. This is the last vector, suppose in this particular direction. The closing vector is in the opposite direction. This vector is coming like this vector is going like this. This is a closing vector. Like that, n number of vectors you can put in the polygon loop, and as the number of vectors are reaching, if there are n number of such vectors, sides of a polygon, then the resultant will be 0. Now, let us solve some simple problem. If A plus B, mod of A plus B is equal to A minus B, prove that the angle between them A and B is 90. So already you know, suppose A plus A is one vector, A is one vector, okay, B is another vector, then R will be equal to A plus B, A plus B, but the magnitude will be given by, this is the formula, R will be the magnitude. Suppose suppose what is the resultant of vector A and vector minus B, then in place of B you have to put minus B, then the resultant will be equal to R is equal to A square plus B square minus 2AB cos theta. This is the resultant. So magnitude of A plus B is equal to A minus B. When you put in this particular fashion, then you apply the formula, then simple mathematics, square on both sides, root cancel, then this A square B square cancel, then 2ab cos theta is equal to minus 2ab cos theta. You bring this side. 4ab cannot be equal to 0, so cos theta is equal to 0. You know cos 90 is 0, so theta will be 90. So if magnitude of a plus b is equal to magnitude of a minus b, then theta will be 90 degree. Okay. Another problem. The vertical component of a vector is equal to the horizontal component. What is the angle made by the vector with x-axis? So what is the condition given? The horizontal component is a cos theta. Horizontal component is a cos theta. And what is the vertical component? Vertical component is a sin theta. So if both are equal, if ax is equal to given condition, ax is equal to ay. So if ax is equal to a cos theta will be equal to a sin theta, a cancel, tan theta is equal to 1, theta will be 45, because you know tan 45 is 1. So if both the component is equal means angle will be 45 degrees. Now another problem, if two forces of magnitude 3 units and 5 units act at an angle 60 degree with each other, what is the magnitude of the resultant? Already you know the formula for resultant, just PQ is given and theta is given, just you substitute, you will get the answer. What about this problem? A is equal to I plus j, what is the angle between the vector and x-axis? So what is the given vector? I plus j. So first you need to find out its magnitude. Magnitude is given by square root of 1 square plus root 2. So what is the formula? Ax is equal to magnitude of a into cos theta. So therefore what is cos theta? Cos theta will be equal to ax by magnitude of a. That is what is given. Okay, a ka magnitude is root 2. So if cos theta is equal to 1 by root 2 means theta, you know cos 45 is 1 by root 2. So the answer is theta is equal to 45 degree. Now this is a very important concept under this motion in a plane. This is called river, boat or man problem. So what is this river, boat and man problem? Suppose you imagine there is a river. This yellow line is river. Now velocity of river is represented by this arrow Vr, and the width of this river bank width is d. D is the distance between from this bank to this bank. Now what is the problem? Problem is a boat or a man is starting from here, he has to reach B. The person has to reach B. This is the shortest distance, direct perpendicular distance. So what is the condition for normal, that is perpendicular reach? A to B is the shortest distance. What is the condition? And then if river flow is there, then what is the condition? Actually river is acting in x direction. Velocity of river is in x direction. So the person from A cannot reach B. So to reach B, how he has to start? He has to start at some angle. Let's say he starts from A at some angle. This is the velocity of person at an angle theta with the vertical. AB is the vertical. So now what you do is, this is the velocity of river in x direction. You resolve this Vp into two components. Vp cos theta, horizontal component, and Vp sin theta, vertical component. Now what is the logic? For the man to reach from, or the boat reach from A to B, there should not be any net horizontal velocity in x direction. Now there is a velocity in x direction, no velocity of river. So boat is being pushed in positive x direction. But very cunning manner, what is being done? What is done actually? This Vp is resolved into two components, Vp cos theta, Vp sin theta. You can see that Vp sin theta is exactly opposite to Vr. Vr is in east direction, Vp sin theta in west direction. If these two are equal and opposite, then there will not be any net velocity in the x direction. So this is the condition we have to utilize. So for the person to reach from A to B, there should not be any, there should be no net velocity along x direction. The condition. If the boat or a man has to reach from A to B, The condition is there should be no net velocity along the x direction. So what is the condition? VR should be equal to Vp sin theta. If VR is equal to Vp sin theta, then what is sin theta? VR by Vp. Similarly, so theta will be equal to sin inverse VR by Vp. So the angle at which the boat has to or the person has to start is angle is this. So if sin theta is this, you know that what is cos theta. Cos theta will be equal to, because sin square theta plus cos square theta is equal to 1. Cos theta will be equal to 1 minus sin square theta. So it will be equal to 1 minus sin theta is this. So it will be VR square by Vp square. Then other part of mathematics, Vp square minus VR square, Vp square will come outside as Vp. This you can substitute. And the time taken, what is the time taken by the boat to reach from A to B? Now time taken, who is helping the boat to reach B? This Vp cos theta is helping the boat to reach from A to B. So the time taken for the boat to reach from A to B is time is equal to distance of approach by velocity of approach. Distance by velocity. So distance divided by what is the velocity? Vp cos theta along AB direction. So time to reach B is equal to T is equal to D by Vp cos theta. This is the general formula in a rain boat problem. In river boat problem, this is the general formula. Okay, now next case. So time to reach B, we have arrived here. Just now I told you cos theta is equal to square root of 1 minus VR square by Vp square. If you simplify, you will be getting D by square root of Vp square minus VR square. So if you know these particular values, you can find out the time to reach from A to B. Now what is the minimum time taken? What is the minimum time taken to reach from A to B? Minimum time, already you know that time ka formula is D by Vp cos theta. This formula we already got. So if you put cos theta, theta is equal to 0, cos 0 is 1. So minimum time will be D by Vp, as if the river velocity is not there. Distance is there, velocity of person is there, minimum time will be equal to D by Vp. Then the person will go from A to B. Person can easily reach A to B. Okay, this is the condition for the minimum time formula. Now another thing, you have to find out the drift. Drift means how much, see, some angular displacement is there, no? So same diagram you can draw like this. Suppose this is VR and this is Vp. This is the resultant. Okay, resultant of the person. So the person will reach here. So this is the drift. So in minimum time, what is the drift? That is the question. Velocity of river is this direction. So already you know that minimum time is D by Vp. So horizontal direction is Ux into T. What is Ux? Ux is equal to Vr. Okay, velocity of the river. So Sx is equal to Ux into 2 means in place of Vx you put Vr. Vr into D by Vp. That is equal to, drift is equal to D into Vr by Vp. This is the drift formula. If they are asking the drift, this is the formula. Now let us solve some simple problem. See, width of the river is 500 meter. Velocity of the person is 2 km per hour. Velocity of river is 1 km per hour. Angle at which the drift is minimum. And you have to find out the minimum time and drift. 3 questions they are asking. Now, this is the river. Width of the river is 500 meter. Let's say 500 meter. And this is the point A and this is the point B. So the velocity of the person is 2 km per hour. So the person has to start in this particular direction. This is the velocity of person is 2 km per hour. Okay. So it is at some angle. Now what you do? Same logic. You resolve this to this VP, this velocity into horizontal and vertical component. Horizontal component is 2 cos theta, vertical component is 2 sin theta. And the velocity of river is 1 kilometer in the x direction. For the man to reach from A to B, there should not be any net horizontal velocity. In that situation, this 2 sin theta should be equal to 1 kilometer per hour. If these two vectors are equal and opposite, no. So there is no net velocity in the x direction. So 2 sin theta is equal to 1, sin theta is equal to half, theta will be 30 degree. So at 30 degree angle, the boat has to start to reach from A to B in minimum time. So what is the minimum time now? Minimum time is nothing but distance by velocity. Distance is 500 meter, you convert into kilometer. 500 divided by 1000. So it will be 0.5 kilometer by 2. And what is the drift? I told you horizontal velocity into time is a drift. So horizontal velocity VR into minimum time. So VR is 1, minimum time is 0.5 by 2. You will be getting 0.25 kilometer or 250 meter. Okay. Now next, another interesting problem. What should be the angle so that the swimmer can reach at B directly? See, in this problem, A and B are at some angle. It is not, direct. Direct means B has to be here. B has to be exactly here. Okay. Now, what is the given? A to B angle is given. Okay, let's say with respect to this, VP is this vector. Okay, so they are asking already this angle is 30 degree initial. Because of this velocity of the river, the boat is going like this, it is subtending an angle theta. What angle it should go so that it reaches B directly? That means this B will come here. B will come here. What is that angle? Let's say B comes here. What is the angle? This will reach like this. So now this theta you have to find out. So what you do is you resolve this VP. This is VP into two components. One is horizontal component, another is vertical component. So along 30, this VP will be VP cos theta, this will be VP sin theta. This will be VP sin theta. Similarly, this VR, this is the velocity of river, this is the velocity of river, VR. VR also you resolve into two components. One along here, this will be horizontal component, VR cos 30, and vertical component as VR sin 30. So you can see that technically these two vectors are equal and opposite. Now another important thing technically, if the boat has to reach from A to B directly, both the velocity has to be equal. VR has to be equal to VP. This is the condition. No net velocity perpendicular to line AB. That should be the condition. VR has to be equal to VP. So now after resolution of vector, VP is resolved into two components, VP cos theta, VP sin theta, and VR is resolved into two components, VR cos 30 and VR sin 30. These two are equal and opposite. Equal and opposite means this VP sin theta is equal to VR sin 30. Already you know that these two are equal. The condition for the boat to reach from A to B. So sin theta is equal to sin theta means, which implies that theta will be equal to 30 degree. Are you following? So this theta has to be 30 degree for the man to reach from A to B. So this is another problem. Okay. Now we start rain man problem. So this is rain falling vertically. This is man at rest. This is the man. Rain is falling vertically. This is the velocity of rain. So here you can see that he has to hold the umbrella as shown, perpendicular direction, VR. Umbrella he is holding perpendicularly with respect to the ground, because man is at rest, rain is falling vertically, so this is the situation. But actually what happens, suppose the man starts running with some velocity, this is Vm is nothing but velocity of the man, velocity of the rain is like this. Now when the man starts running, what he will see is, he will see the rain hitting the man at some angle, not this situation. He will observe the rain hitting him at some angle. So this arrow, this one, this is the velocity, this is the direction in which rain appears to fall. So this is the velocity of rain with respect to man. Okay, this vector is velocity of rain with respect to man. Okay, so Vr is this original one, and Vm, actually the man is running like this, but the rain is hitting in the opposite direction. So we have to resolve the vector Vm from west to east, from east to west, like this you write, because the general formula is Vrm will be equal to velocity of rain minus velocity of man. So you have to, it is nothing but velocity of rain plus of minus Vm. This is actually the formula. So minus Vm is like this. So you write the vector like this. So this is the result. So you can find out tan theta. Tan theta will be equal to this opposite by adjacent. So opposite is Vm by Vr. Are you following? All those things you can find out. So here it is, this is the man's frame now. Man is observing the rain falling like this. This is the velocity of rain with respect to man. So, and as the angle is, as the velocity of the man is increasing, speed of running is increasing, this theta is also increasing. So, as Vm increases, theta increases. Because why? Because tan theta is equal to Vm by Vr. If Vm increases, means theta also increase. Okay, so this is what? This is your Vr, this is your Vm, this is your Vrm, this is the angle theta. So tan theta will be equal to, opposite by adjacent. Opposite side is Vm, parallel to this. Opposite side is Vm, adjacent side is Vr. So tan theta is equal to Vm by Vr, and the resultant Vrm will be equal to square root of, you can apply Pythagoras theorem, Vm square plus Vr square. Okay. So this formula already I wrote. Okay. This is another way of representing by using triangle law. This was the initial direction of the man, and this was the initial direction of the rain in the previous this thing. But the rain is hitting the man like this. So this is the velocity of rain with respect to man. So you can also write in this fashion. Velocity of rain is equal to velocity of the man plus velocity of rain with respect to man. Okay, this fashion also you can write. Okay. Now, this is one problem. A man standing on the road has to hold his umbrella at an angle 30 degree with the vertical. Okay, this is the first situation. The man is holding this particular umbrella. So from next class, I will discuss from this particular problem. Next class, I will continue. Thank you very much.